All right, graphing reciprocal functions. It asks for the reciprocal of both of these, right? Not the absolute value. Okay. Hey, anywhere you see a 0, we're going to have an asymptote, right? 1 over 0 is undefined. And anywhere you see a 1 or a negative 1, that will stay 1 or negative 1. So there's a 1, there's a 1. There's a negative 1. This one's going to be sneaky right there. It's going to be sneaky. Get ready. It's sneaky. And this one is nice too. Now, wherever our numbers are very small or very close to 0 like that, they're going to become very big in that same direction. Okay. If you see a maximum value at 1, you should think, thank you very much. That's like a little kiss, right? That's a kiss. It's like, okay. Do I see a kiss here too? Yep. Right, now this one's like half a kiss. This is like in the movie, what's the movie Will Smith? Albert Brenneman. Hitch. He's like, you go 90, but then let them come the other 10%. Let them come to you, right? So, I don't know why that had to do with anything, but it did. Okay, and it worked. Oh, so that's the inverse. Sweet. Anywhere it's 0, the reciprocal will be, I said inverse, that's wrong. Anywhere you see 0, that will become an asymptote. Anywhere you see an asymptote, that'll become 0. Anywhere you see a 1 or a negative 1, it'll stay the same. Okay, so this one is straight funky. Okay, this is straight funk and fun. Okay, so vertically, do I see any points that equal 0? I see one of them. Here's the asymptote. Okay, do I see any values where I get a 1 or a negative 1? Well, yeah, somewhere in here, right? Let's say like that's 1. Okay, so that point will stay the same. To the left of that point, the values get really big. So when I take 1 divided by really big values, I get really small values that approach 0. To the right of that point, but to the left of the asymptote, I get really small numbers, which means those values get really big. This is really filthy. This is awesome. Now, to the right of the vertical asymptote now, I'm gonna guess, halfway in between would be negative 1, which is a good guess. And so that point will stay the same. As we go to the left of that, those numbers are going to get really large in a negative magnitude, and we will slowly approach 1/2. We will approach, okay? And this is not something you'll be tested on, but we'll approach negative 1/2. It won't approach 0. Ooh, that was a really good dotted line. I'm impressed with myself. It will approach 1/2. Why? Because this function is approaching negative 2, but never reaches it. So this one will approach, but never reach negative 1/2. Oh, sick. Choo-choo. I'm going to do B here, except I'm first going to do it like this, 1 over f of x. And then all I'm going to do is scale each of those values by 2. Okay with that? Or do I need to do it? No, just do, now that won't scale any zeros, right? But that'll stretch everything vertically positive and vertically negative, but it'll keep the zeros the same. That's pretty cool. Choo-choo. What would this one over here do? A. And then shift it right 1, right? You do the reciprocal and then shift it to the right 1. Oh. I just wanted everybody to have to look at this picture on this video. Okay. Cool. Actually, I do want to sketch one of these. I don't care which one. Let's pick one. Preferably one that I can factor. Can I factor B? Yeah, I can factor B. -3, -3. Ooh, that's a weird one. Okay, so if I factor this thing, that would be x minus 3, x minus 3, which is a parabola that opens upward and just touches the x-axis there at 3, right? It just bounces off. Multiplicity of 2 on that 0 of 3. Okay, so I would have a vertical asymptote here, right? Because anywhere it's 0, it's undefined. I would have values of 1. I'm going to use a different color here. How about blue? There and there. And then the sketch of this should look like... Sweet. That's cool.